For f of x equals absolute value of x minus 1 plus 2, what is the new function g of x resulting from a vertical stretch by a factor of 3? Now, vertical stretch means you're multiplying all the outputs by 3, so g of x equals 3f of x. So that means g of x equals 3, and then it's going to be times everything. Absolute value of x minus 1 plus 2. So then I'll simplify this just a little bit. G of x equals 3 absolute value of x minus 1, then plus 6. So I distributed the 3 to the absolute value symbol and also to the 2. Now don't distribute further here, you're done. Okay, let's compare f of x and g of x by graphing. So f of x is absolute value of x minus 1, then plus 2, and g of x is 3 times the absolute value of x minus 1, then plus 6. Let's graph and compare. So there's f of x in blue, and there's g of x in red. So we're saying that's a vertical stretch by a factor of 3. Now, vertical stretch means it's going to be stretched 3 times relative to the x-axis. So the vertex here for the f of x is up 2, and the vertex for the g of x is up 6. So this is a vertical stretch by 3, and in this case, if you look at the table, you can see that more clearly. Input of 1, output of 2 for f of x. Input of 1, output of 6 for g of x. And in fact, if you look at all these inputs here, and then compare the outputs for the f of x and the g of x, all the outputs are multiplied by 3. 3 times 3 is 9, 2 times 3 is 6, then 9, 4 times 3 is 12, and so on and so forth. So that's definitely a vertical stretch by 3. So this g of x is definitely the vertical stretch by a factor of 3 for f of x.